Artsem, and today we would like to say a few words about Delta Live tables, about Databricks, and all the stuff. 50% it will be just boring presentation, and in the end, if nothing will be broken, I will actually show some kind of demo. I actually prepared a slide about myself. So my name is, one more time, Artsem, and all of my time in IT I'm actually working at EPAM, so it's around 5 years. All of these years are related to data. About half of this time I'm actually working with Databricks and Azure, and to be honest, it's my favorite part because it's quite easy to use, it's quite fast, but unfortunately sometimes a lot of challenges with costs. And yeah, Azure data certification as usual. What we will be talking about today? Actually about Delta Live tables, why are they so cool, why are they so bad, but before we proceed with actual Delta Live tables, I would like to perform not deep dive, but just say a few words about data warehouses and Delta Lakes, why we actually need these Delta Lake tables, a few words about Medallion architecture, and yeah, then we will proceed with Delta Live tables. Because I'm actually coming from the data quality world, and I'm actually head of data quality in Databricks in EPAM with around 20 people, sorry, I will steal some time to tell why data quality is so much needed and why sometimes it's being skipped. And in the end, it will be a small demo. We will actually build really small but interesting Delta Lake. So without further ado, talking about data warehouses and data lake, I think that actually most of you knew about data warehouses and about data lakes. But if we are talking about I don't know, 10 years ago and more, it was mostly classical data warehouses for storing the data to build Power BI, sorry, not Power BI, to build actual dashboards and all the stuff. And actually it was perfect time because data was perfectly structured and it was very high optimized, it was working really fast. But unfortunately it is a few disadvantages because this data, we could work with data warehouses only using SQL. And it's really hard to scale these solutions up because basically it's just normalization needed, all the stuff, and it's really hard to add more and more into the data warehouse. The good thing is that it actually supports ASIC, so it's basically atomic, consistent, isolated, and durable transactions. So level of data quality is just amazing. Talking about data lake. Just as you know, amount of data is constantly growing, and we have something, I don't know, 200 zettabytes at the moment, and each year it's growing more and more and more. And it's not only about tables and all the stuff, it's more semi-structured and non-structured data, like text, videos, and all the stuff. So the good thing that we are just putting everything into the data lake and we are not caring about it at all. So yeah, it's working really fast, it's working really cheap compared to data warehouses. But my personal pain is that in data lake the quality of the data is going down, down and down because costs to maintain data quality is needed more and more, and it's not so much effective. And yeah, unfortunately we don't have any kind of asset anymore. So that's why some kind of need for data lake pop up. And Delta Lake is not actually data warehouses or data lake. It's not system on its own. It's actually just an open source storage layer that we building on data lake. So basically we are just gathering good things from the data warehouse, creating based on this Delta Lake, and integrating it into the data lake itself. So the good thing is that it allows us to asset transactions again, and it's also allows us to work with batching and streaming data in a unified way. And one of the most interesting things is actually data versioning, slowly changing dimensions. So yeah, it's still possible to build them in data lake by integrating Delta Lake on top of this. Just a little bit of schemas. Sorry for the white font here. Delta Lake is generally looking like this. So just a few words that, yeah, as a source we can have basically anything. It could be cloud, it could be SQL Server, simple files, and so on. And as the output, our favorite machine learning, artificial intelligence, all the stuff, or simple reports, Power BI, and all the stuff. What I would like to say about Delta Lake and Medallion architectures is that here you can see it's bronze layer, silver layer, and gold layer. They're a little bit like actual like source, staging, landing, data warehouse and data marts level in the traditional data warehouse, but just a little bit different. Long story short, bronze layer we're just gathering all the data as is, we're not caring about anything, and silver layer we're cleaning this data, and on gold layer we're just aggregating the data. Just a little bit more details. So one important point about bronze layer. We're actually not expecting to update some kind of data or delete some kind of data. When we're loading something into the bronze layer, it is append only. In case if it's not append only, that's really a bad idea, because basically it will be hard to store source information and so on. So as it mentioned here, all records should be retained, if possible, for the quite limited exceptions. And basically, it's our source. We, through streaming or from batching data, we collected everything into the bronze layer, and then this data is being like proceed fused for silver and gold. Silver layer is pretty simple. It's just data from the bronze layer, but cleaned. What I'm meaning when I'm mentioning cleaned? Data should be deduplicated. Data should be actually like cleaned up from some kind of incorrect values, because in one of the projects when I was working in EPAM, I'm actually working there still, it's sometimes age, like -20 for example, or some crazy amount of transactions and so on. And on this layer we're introducing actual data quality, so we are just cleaning this data. And with the gold layer, everything is pretty simple. We are just gathering data from the silver layer, but we are just aggregating, joining it, and so on. So we can think about this some kind of enrichment, joining tables to use them for star schema, for data marts, and all this stuff. One very important point here is that actually when we're talking about like Medallion architecture, sometimes it's like platinum layer in some of the cases, and actually it's about like Medallion architecture, data quality dimensions, which I will cover in the next slides. It could be like a lot of different variations, but by design, as original, it's only like 3 Medallion architectures. Why I mentioned data quality? Because that's unfortunately the part that is being skipped sometimes. Because budgets are being cut on the project, and we are like getting more and more of the data, then the data is being like non-ideal, let's say it like this to avoid bad words, and then we have some kind of issues with like end result, and business is not doing like good predictions, losses of money, and so on. So data quality is a must, and generally when we're talking data quality, it must be aimed on 3 targets. So it's actually process, data, and system. Talking about system and process, everything is pretty simple. So when we're mentioning system, it's just like the whole data warehouse, the whole data lake. So basically the whole system that we're checking. While we're talking about like process, we're jumping into more and more details. So for example, that all our connections are setting correctly, that some kind of data transformation is performed on boot layer, level. But talking about data, it's really complex stuff, and trust me, from my experience, we have these beautiful 6 data quality dimensions, and I would like to start from accuracy, because 3.5 of my years are related to like reinsurance domain, so it's not like insurance, it's completely different stuff. When reinsurance companies are basically reinsuring a lot of contracts from other companies, and this data is really hard to catch, because when we're talking about accuracy data quality dimension, it is meaning that data should reflect the real world. And it's really hard to understand how it is reflected in the real world if you are not like understanding the business in general. But when we're talking about like other data quality dimensions like timeliness, consistency, completeness, accuracy, and uniqueness, super easy to check. Like uniqueness, you just don't have any duplicates. That's good. It's fast. When we're talking about timeliness, as an example, the data should be arrived in some place for 4 p.m. because report will be refreshed at like 5 p.m. consistent as it's consistent across the sources, that like one transaction in different system will have the same meaning, and completeness that the data, for example, is loaded from like silver to gold without any transformations, and validity, the data is represented in the same format. So, for example, we shouldn't have a situation when it's like y in lowercase, y in lowercase, and all this stuff. Going forward about data life tables, again, just a high-level overview. Delta, what is very important to like catch here is that Delta life tables is actually not like a tables itself; it's a framework. So in Databricks presented these Delta tables, which supports versioning. So you can like take a look what with the data today, what was like before, yesterday, and so on. But Delta life tables is actually a framework to operate with data. We'll talk about this a little bit later in details. And yeah, we can have like batching, streaming, basically anything, and the result, everything is going into Databricks, SQL, Python, or like any other languages. Talking about Delta life tables data sets, very interesting point that actually it's not like tables itself presented, like in classical data warehouses and so on. We have only views, materialized views, and we also have streaming tables. And actually we have only like materialized views and streaming, because views are just to some kind of insights. So for example, when you would like to understand what is the current state of data quality, you would like to take a look at the data and so on, you are creating view, executing this view, and all good. But in streaming table, we're just getting all the data, saving it as a table, we're working this one, and again, it preferably must be append only, so we're not expecting to change anything. And the materialized views are perfect for saving some kind of data in moment, like to save some state of the data, like how it was 1 hour before, 2 hours before, and so on. So in case if anything broke in production, which happening quite often, then we will take a look at the data. Talking about sources and ingestion, we can use for Delta life tables basically anything. Today we will create a demo and example using Azure Internet of Things Hub. But it could be used autoloader, it could be used message bus, some kind of external systems, and so on. But the best idea is to actually use like message bus, because in this case it's more like cost effective, and Delta life tables are working just brilliant with streaming data, not with batching. With batching it's working like brilliant too, but we have some other alternative like standard Spark streaming and so on. Talking about benefits. I would like to start from actual drawbacks, because it's expensive compared to other systems, like simple Spark Stream. And from my point of view, it's usually and all the times some kind of trade-off. Should we involve more engineers to create something just with custom code, or we're just investing some like money into the Delta life tables itself? But Delta life tables is just amazing for a situation when you need some kind of, some situation on project in red, or we need to perform some urgent analysis on data, like we need to involve some Ninja or SWAT squad. We're just creating Delta like pipeline, and everything is quite fast and easy to set up. Also, from good thing, it's data lineage, traceability, that it's easy to like understand how the data is flowing. It's being built automatically without need for some additional system connections and so on. Pipeline is visible, and in case if needed, we can like get the statistics for every table. Going forward, one of the actual main benefit, which is amazing for a situation when you need to understand how the data was changing, what was like added, removed, and so on, it's change data feed. So on the example, you can actually see that initially it is just 3 rows like A1, A2, and A3 with primary keys. And let's assume that some change with data happened. So that for A2 row something changed, that A3 row was just deleted, and the last row was inserted. And in the result, we have this change data field output, where we can see actually what was the state of the row second before like some kind of change, what is after the change, what row deleted, and what row was inserted. But very important point here that is not actually covering the rows that are not changed, deleted, updated, removed, and so on. So here in our example it's only one row, but actually it would be like 1,000, million, and so on, and in change data feed it will be reflected on the rows that actually change somehow. So it's really good in the matter of actually spotting out some kind of changes, and also for cost efficiency and so on. And yeah, it supports slowly changing dimensions of type 1 and 2, but not from the box. Again, some like, additional transformations needs to be performed, but it's easily could be done within the Databricks itself too. Going forward, here you can actually just ask why we need like this delta-like tables if we have just Spark structured streaming pipelines. And as you can see, like on the top left on the slide, it's actually quite a lot of things. So they both could be integrated in Unity catalog. They both could ingest from a lot of sources, both like powered by Spark structured streaming and so on. So again, as I mentioned like several slides ago, in some of the cases, if it's especially when we're aiming for the costs, using just Spark streaming pipeline is a good solution. But if we need like data quality, error handling, continuous integration delivery, it's already in the data live table pipelines. It's working really good and fast. And especially good that it have quite good level of compute autoscaling. And just a few words about theory before the actual demo. So, as I mentioned, it's really good for actual creating of data lineage and traceability. But from my point of view, one of the best things that we can just use great expectations. Direct expectations is really a simple library framework to work with data quality, and it's working both with batching and streaming data. It could work with both Python, it could work with also SQL without any issues, and we're just putting some kind of expectations on the data. And actually I had a few discussions with colleagues from different projects, and easy to set up, but really hard to collect information from the business, what kind of checks we're expecting and so on, because yes, it's easy to say like that column should be nullable, that column should be negative, but if we are talking about like more complex cases, like some kind of formula, some kind of expectations, it's getting more and more complex. So yeah, that's basically it from the theoretical point of view. I would like to show just a really quick demo and what we will be doing right now. Again, sorry for a white slide. We will create our delta live tables and small delta lake with all 3 layers, and as an input we will have Raspberry computer with which will integrate data into the Azure Internet of Things hub. So unfortunately I don't have a physical Raspberry device, but we can just go to the Microsoft side. And actually, Microsoft providing Raspberry Pi Azure Internet of Things simulator, which is super easy to use, super easy to integrate with Azure Internet of Things Hub. So basically, if you are just will open the site from scratch, and the only thing that you will need to do is to basically add connection string. In my example, the only thing that was changed and to which we will refer if we will press reset, it will connection string will be blank, and also some of these parameters like RPM and angle will be like missing. But in our case, let's assume that it's streaming device which giving us some information about temperature, humidity, basically about weather, wind, and so on. And we would like to integrate this data into delta live tables. So working super simple, we are just clicking run, and as you can see, data is started to send into the actual Azure. So like message ID 5, 6, 7, and so on and so on. Sorry, but data is fully dummy. It doesn't have any kind of business meaning. It's random, it's auto-generated temperature, humidity, and all the stuff. All the stuff is being sent actually to Microsoft Azure, and here we have Internet of Things Test Hub, where the only thing that I basically done is created this like test device. Yeah, it's appeared. And from this test device, we are getting actual primary connection string, which we're just putting into the Raspberry simulator, and it's working. But before we proceed with Databricks, just a little bit of initial setup needs to be done. It's actually built-in endpoint, so basically that our data is being sent back. And here is actually endpoint that will be user used. But before proceeding with Databricks, let's actually check that our data is being sent, and here you can see that number of messages is being used. To be honest, I'm not quite sure, is it like from the past like minute, or is that I executed like half an hour ago, because sometimes this sync is taking a little bit of time to sync between the systems and so on. But yeah. What else I can say about like Internet of Things Hub? That as we see, the time currently I'm using fully free Azure subscription. It's not costing me anything, but it's given some restriction of the Databricks. And for example, this stuff is costing, I don't know, around like $20 per month, and can receive like lots of messages per day. So here we're just seeing the general statistics and so on, and let's proceed to actual Databricks. I hope that with black theme everything should be visible, especially when we're talking about the code. And let's talk a little bit about like Delta Live Tables demo. So long story short, it's pretty simple. If we just run through this really fast, it's just setting up all the parameters. We're creating one table on the bronze layer, second table on the bronze layer, like one silver, second silver, and we're aggregating into the gold. Let's talk about this a little bit into more details. So before we start, on the top right that you can see that this notebook is actually associated with Delta Live Tables pipeline, and it's really one of the cool things about Databricks in general, not when we're talking about like Delta Live Tables itself, that you are just passing the notebook and the pipeline is being created, everything is working, everything is good. When we are talking about Delta Live Tables, here as you can see we need to actually import them, so just one line of code, no relations, and this could be ignored because it's just importing some PySpark model to work with. And here we are just passing some parameters which are being extracted from, just a second, from this endpoint. Yeah, definitely we could just copy this and use as a hard code, but not the best approach. So here we're just creating connection string, and actually we will be using Kafka listener to get the streaming information. So here we're like basically connected, we set up listener, and also one thing that needs to be specified, it's actual schema. So it's basically column name format, column name format, column name format, blah blah blah. It's like the same as our beautiful Azure devices sending here. So let's proceed with creation of the tables. Again, pretty simple because we just using Python decorator, create table, we are passing like a common with table name, and in the function everything is super simple. So we are setting that we will read schema with Kafka, we are passing like options that data will be loaded. Here I'm renaming some of the columns, and in the result like table we are selecting some of the columns. So basically nice and simple. So this for bronze turbine and bronze weather. Actually, it's being selected from the one stream, but in the matter of time, let's assume that it's two different devices or two different tables. And that in this first one, we actually have like turbine about the window and about the wind. exactly. Thanks for this one. Wind and so on. And for the second one, it's just about the weather and temperature. Talking about silver layer, it's basically the tables from the bronze layer, but we're actually adding some constraints that, as I mentioned, using great expectations. So here we're setting that some columns should be null and some columns should be higher than 0. Very important point here is that in the first part we're actually saying that expect or drop. In the second part we are saying expect or fail. What is actually meaning? In the first option, in case if we will receive incorrect records, this record just won't be loaded further. And when we're talking about the second option, the whole pipeline will fail and go to restart depending on the is it production mode or development mode here. Just a few words about actual data expectation, sorry, great expectations. Here just a little bit of the things that I just said and so on. I just want to highlight that it's really it's really good being set up in the Databricks itself. It's have beautiful documentations and so on. It's super easy to work on simple checks, as I mentioned, but when we're talking about more complex business checks, the main principle will be the same, just a little bit of code needs to be added. And the same thing about the silver layer we are doing for the silver weather table, and in the result we are joining everything into the gold layer. So basically here we are reading information from the one silver table, from the second silver table, and we are just joining these tables back between each other because it's dummy data and just for demo purposes. Here we should talk about delta life tables itself, so it's how they're looking. In the matter of time, I won't be starting this pipeline because it's really tricky. When I was preparing, sometimes it is taking just 3 minutes, sometimes it's taking 15 minutes to wait for resources, allocate these resources, and so on. And I don't have enough material to entertain you for just 15 minutes while it will be waiting for resources. But generally, when we are creating pipeline, it will be waiting for resources, initializing, setting up tables, and as a result, we will have some places. So before we proceed with pipeline itself, I would like to show how easily it's being created. So pipelining is easy, product edition, just put into advanced depending on subscription and so on. And pipeline mode, here it could be triggered and continuous. As you might guess, triggered is going for actual batch loading, continuous is going for streaming. So in my example, pipeline is actually created for continuous, it is just loading data and that's all. In the source code, as I mentioned, we are just passing the notebook. So in the example that I will be showing just a little bit later, this notebook is being selected and everything is working quite good without any issues. Storage again Unity or Hive, storage location target schema, and where it will be saved and so on. And for demo purposes, I actually use simple fixed cluster with 0 workers because for 5 workers it's costing 6 Databricks unit, and I'm not quite sure how much it's dollars, euros, and so on because it's really dependent from the location. It's a lot of things, but when we're executing simple cluster with a compute of 0 workers, which is more than enough because we don't need any kind of management and so on. It's hosting only 1 DPU and it's working fine, but just unfortunately it's taking too much time to initialize and wait for resources, or at least for me. Notification, advanced, nothing interesting to focus here. So in the result, it's looking like this. And here is actually a simple example of data lineage that I mentioned, because Databricks on its own is building relation between the tables, and it could be easily visualized. It is also list being presented here, but it's not it's not even looking as good as rough. Data lineage is not only definitely in Databricks, because, for example, on my current project in EPAM, we are using like Stargate/Palantir, and sometimes it's really complex data dependencies where one table in one table is flowing, I don't know, something like 20 tables, and everything like crossed out between each other, so it's looking quite like interesting and complex. So in like static, it's looking like this. When the data is being loaded, it will be like this, just green color and so on. So the idea here is that in bronze we are loading streaming, on silver we are cleaning some data, and in the gold we are saving the final result. Just want to highlight that here these 4 tables is streaming, and the last one is actually materialized view. Also, one of the good things from my data quality part that I like, that we just could go to this tab without need to create some additional views, refine the data. We can just take a look at the data, okay, and so on. Fortunately, dummy data during this execution generated okay, and we don't have any kind of drop records and so on. Last moment that, as you can see, it could be like development, production, and the only difference, at least that I find out, that in development, when something is failing installed, in production it will be like trying to retry again and again. And as you might imagine, it's really not cost effective, because if you leave it for several days with retries, it could be like lots of money wasted out, because no business meaning result, but just retrying. So that's why we actually need notification. So that's how the generally pipeline is looking in Delta Live tables. One very interesting moment that actually, just a second, the thing that I just shown to you could be also achieved by SQL, because to be honest, I prefer SQL more than Python. It's much easier to understand and work with, but unfortunately we can't just use so much functionality in like SQL compared to Python. But as you can see here, like constraints is being set like this, and basically the great expectation is working on same level. Just SQL usually taking a little bit more time, which leads to again more DBU usage and so on, which is not good. And actually I didn't find a way, or maybe I didn't allocate too much time for this, how to actually load into the live table in SQL using like Kafka, like I did. So here, sorry, I just used select star from tables that were already created. So just a few more words about Delta Live tables. Just a second, open the notebook and change data feeds that I mentioned. So here you can see 2 rows. Usually when you're working with Delta Live tables, when you would like to have this change data feed on the cluster level and all the table, it is being enabled automatically. So, but just in case if a cluster previously was created for some kind of other purpose, or in case if a table wasn't created by Delta Live tables pipeline, in this case we need to set this change data feed to true to have this functionality. And here, what is really good for data lake, we have history of the table. So for the streaming, I think that it's when each version being created quite often. So it's something like even like 5-10 seconds sometimes. Again, it's could be configured depending from your needs and so on. But on one of the projects where I was working with Databricks and AWS stack, it was really good because, for example, new version is being released. It has version like 190 and something is not working correctly. You are just taking a look at the previous version and checking that everything is good. But it please be very careful with this versioning, because if we are talking about like real life example, not about the dummy data, it doesn't make sense to store all the versions. Maybe it is making sense, but in this case it will be really, really expensive, because it will be a lot of storage wasted for this part. So yeah, also we could like describe extended on the table, but generally it's like select star information schema in data warehouse. It not giving too much useful information here, just general statistics about the table. And here, actually, let's hope the cluster result. Let's like insert some data into the table. I already like performed update, and I already performed some deletion and so on. And here, yeah, we just not returning any kind of input here, sorry, result. And in the end, we have this beautiful table change table within Databricks, which is actually like working like slowly changing dimension. But it is like maybe not so good readable as slowly changing dimension, but it's already integrated into the delta live tables. It does not require any kind of additional scripts running and so on. And here, basically that's the things that I was showing during the presentation. We can take a look that some record was inserted, to what like version it was inserted, what is like the general record, like values of each column and so on. For insert and deletion, it's pretty simple, but my favorite is actually update, because here we can take a look at the previous value, and here we can take a look at the like last value. So because in our example we were updating like annual to 50, and as you can see here it is being reflected in the data. So again, it is a good question, is it really needed for all data lake projects? Because if we will like create this everywhere, it will be like lots of cost, lots of engineering and so on. But again, in cases when you need some deep dive investigation, what happened with data, especially if this data is being changed quite fast, it's really a good choice. What I would like to highlight also on what point I would like to finish, that this kind of tables could be easily transformed into the slowly changing dimension too. So basically, we are just passing the actual table name into the spot, and we are creating a streaming table. Basically, from the tables that I just showed with update, deletion, inserted, and all this part, we can easily create a slowly changing dimension type 2. So basically, we are seeing the previous value or some intermediate value and the final value. Just the only difference between classical slowly changing dimension will be that instead of classical timestamp and so on, we will have like start, add, and end add as version inside the Databricks. So I guess that's it. And thanks. Maybe you have some kind of questions.
Yeah, I do have a question. Yeah. Thank you for your presentation. I have one question. Can I run locally all the stuff in my local PC without using cloud, maybe in some Docker image, just to play with it?
For what purpose? Because basically you can take your credit card, you can use free subscription of the Databricks and Azure, and for like 14 days and $200, which is more than
I just would like to make my hands dirty and play with it without like, any additional financial stuff.
Again, it won't be adding some kind of additional finances to you, but honestly, I don't have such experience because I don't know. You know, Databricks is cloud-based and was purpose to move it into the system. But I work with this quite well. Just for what kind of some kind of reason, Revolut cards is not being accepted. Not real. So yeah. I see. You also had a question.
Yeah, I have a question. You showed the pipeline where you had the streaming tables and it's going to dematerialize here. So the streaming tables is updated in real time, right?
Yeah, in the real time. So
and
it's
then
based.
materialized view as well?
Yes.
Or is there like some few seconds dependency? Have you noticed it, or
it's again could be set it up. Usually, materialized view is in this case it's being updated at when the new data is coming into the silver layer and so on. But because it's materialized view, it could be easily set up to some kind of refresh. So it could be 5 seconds, it could be hours. So basically, it depends. But in this example, it was just in the gold table. The new records were shown up just when in the silver table something showed up.
so it's real time?
Yeah. In this case, it's real time. It's not the best for the costs, but again, for this case, it's worked just fine.
But like we can configure it
Yep.
and have some delay.
Yeah, it's really flexible and
Okay.
easy to do. Thanks.
I have a question related to this picture. Is it possible to trace a specific field, as we can make it in Palantir, for example, lineage in Databricks? Does it allow us to trace specific
To
field?
be honest, I'm not aware. It's one of the things that I really like in Palantir, but here I'm afraid that no.
For regular tables, there is lineage.
Mhm.
For DeltaLab tables, I didn't try. It should be possible.
Yeah. Just no, I didn't touch on such experience, to be honest.
And I have another question about like how the problem of small files is resolved and with like
What kind of problem with small files?
like usual problem of Spark tables, like should we make some vacuum optimization or
Yeah,
something like
actually,
that, or
I
it
guess-
is embedded already and we should
I
not?
guess that actually it's performing some kind of vacuum automatically after some time when streaming is completed. As you can see here, during the first 11 version, it was like constant streaming. But in the end, optimize, vacuum start, vacuum end. Again, it could be configured. It's usually being enabled automatically because, as you can see, it's quite small data set. It's less than 50 rows, but here vacuum is like started and ended. Again, if it will be running for days, weeks, and so on, I guess it also could be handled just some kind of partitioning and so on. So yeah, it's a good thing that it's working out of the box. More questions?
No more questions?
Yay!
Thank you.
Thank you.